let's take a look at this example. This table describes the probability distribution for the number of heads when two coins are tossed. They want us to find the mean, the variance, and the standard deviation for the probability distribution described. So we're going to go and use these formulas. Coming back to this one here, we're going to use the mean, we're going to use the variance, and we're going to take the square root of that to find the standard deviation. So what I like to do is I like to actually build a table using the formulas. So the mean is the x times its probability. So I write out the headers x and the probability of x. So they give me the x, 0, 1, 2, and they give me the associated probabilities. So I'm just going to fill those in. And then to find the mean, I'm going to multiply those. So 0 times 0.25 is 0, 1 times 0.5, and then 2 times that here, we're going to get 0.5. Now, the mean is the sum of this column. So I can actually calculate the mean right now by adding these up. The mean is the sum, again, of x times p of x. So the sum of this is 1. So I know that the mean is 1. So I'm almost done with this problem. But now we need to find the variance, and that is by taking x minus the mean squared. So x minus, we know the mean is 1, squared times the probability. X, 1, minus the mean we know is 1, times the probability. 2 minus the mean times the probability. So we're going to calculate each of these. We get 0.25 there, because negative 1 squared, we get 0. 1 squared, so we get that. And then the variance is just the sum of this column here. So the variance is going to be the sum of these. We get 0.5. That's our variance. If we want to take the standard deviation, we get the square root of the variance. So that is going to be, I'll get out my calculator here, square root of 0.5. It's about 0.71, 0.7. And so that is the standard deviation. Go ahead and give these a try. Press play when you're ready to see the solutions. There you go. All right, now let's talk about the range rule of thumb. So the range rule of thumb tells you about identifying significant values. And remember that this means the mean, and this is the standard deviation. So we're basically looking at significantly low values, are values that are two standard deviations below the mean, and 2 standard deviations above the mean. So the values that are close to the mean are not significantly high or low. So basically, that is what we're going to use for this example here. So we found that when tossing 2 coins, the mean number of heads was 1, the standard deviation was 0.7. We just did those calculations. So now we're going to use those results and the range rule of thumb to determine whether 2 heads is significantly high number of heads. So to figure out if something is significantly high, we want to compare it the mean, which we know is 1. And if it's significantly high, it'll be 2 standard deviations above the mean. So that's, we know the mean is 1, we know the standard deviation is 0.7. So when we calculate that, we can kind of come to our calculator, 1 plus 2 times 0.7. We're going to get 2.4. So is 2 heads, is 2 would be right about here, right? 2 heads. So that is not significantly high number, right? 2.4 heads would be a significantly high number. And here's a little bit more detail about that. Go ahead and give these a try and press play when you're ready to see the solution. There we go. Let's talk about comparing probabilities for significantly high. We are going to compare with 0.05. And that number is not particularly rigid. It could be 0.01, but you can use 0.05. So you're basically asking, is that probability less than or equal to 0.05 in it to see if it's significantly high or to see if it's significantly low? So let's look at an example. If the probability of flipping 252 or more heads is 0.0224, is that a significantly high number? So if it's significantly high, we're going to compare it with 0.05. So here's our probability, 0.0224. Is that less than or equal to 0.05? So I like to kind of look at the decimal point. Okay, we've got zeros. Okay, the next number is 2. 2 is less than 5, so yes, this is significantly high. Let's go ahead and give that a try here and press play when you're ready to see the solution. And there we go. Now, if under a given assumption, the probability of a particular outcome is very small and the outcome occurs significantly less than or significantly greater than what we expect with that assumption, we can conclude that the assumption is probably not correct. So let's talk about what we expect in the next section.